Hi class, so today we will learn about chapter 6, which is urinary system. So as we all know, the most important organ in urinary system is kidney, right? Therefore, at the end of the lesson later, you should be able to describe and illustrate the external anatomy of the kidney, the internal anatomy of the kidney, and describe the general functions of kidney for the urinary system, illustrate the structure of the nephron, the functional units of the kidney, and in the function of each part inside the kidney, involving the urethra, urinary bladder, and urethra. And also later you need to also be able to describe the process of the glomerular formation, tubular absorptions, and also the tubular secretion. So now let's look on the structure and the functions of kidney. So kidney have several functions for the urinary system, which is the first one is of course to regulate the concentrations of waste, and then to regulate the pH and also the volume of the blood plasma, to eliminate the metabolic toxin, and also to regulate the concentrations of electrolytes in our body. So the regulations of extracellular fluid environment in the body by the kidney, involving regulate the volume, the pH of the blood plasma, waste, and also the concentrations of the electrolyte. And the structure of kidney is actually a bean-shaped structure, and the urine later will be made in the kidney, where the urine will then transfer to the renal pelvis here. This is our kidney. It will transfer to the renal pelvis and then the urethra. And you have to remember, kidney have two most important region. The first one is the outer part here. The outer part region is known as the renal cortex. Meanwhile, the inner part here is known as renal medulla. Okay, so later after the urine is being made, is made inside the kidney, and you will transfer to renal pelvis, urethra, and ureter will pass it to the urinary bladder, as you can see over here, and then it will exit through the ureter. Okay, and this one we will look more details later. This one also. Okay. Okay, as I mentioned earlier, kidney has two important regions. The outer part is known as renal cortex. The inner part is renal medulla, in which renal medulla is made up of two parts, which is renal pyramids and also renal column. Okay, as you can see over here, this one, okay, is known as renal column. Meanwhile, the region between these two renal column, we call it as a renal pyramid. Oh my god. As I mentioned earlier, the kidney has two regions. Okay, the outer region is known as the renal cortex. Meanwhile, the inner region is known as renal medulla, and renal medulla is made up of two parts or two regions, which are renal pyramids and also renal column. So which one is renal pyramid and renal columns? So as you can see over here, this one is known as a renal pyramid. Okay, renal pyramid, renal pyramid. Meanwhile, the regions or the parts in between these two renal pyramid, here, here, and this one also, is known as a renal column. Okay, so each of the pyramid later, so each of this renal pyramid, and then it will drain the urine into this small tunnel over here, which is known as minor calyx, and then it will transfer to the broad tunnel here, which is known as the major calyx, and then this major calyx later will merge to become the renal pelvis. Okay, and then from the renal pelvis it will transfer your, what we call that one, your urine to the ureter, and then ureter goes to the urinary bladder, and it will exit through the urethra. Okay, so as you can see over here, okay, this is the renal pyramid, the renal column, and this inner part is renal medulla, the outer part is renal cortex. Okay, now we're gonna look more details into the renal blood vessels. So renal blood vessels, of course, inside the kidney itself, they have their own blood vessel. Okay, because they are also organ that need oxygen and needs to diffuse the carbon dioxide, right? Okay, so as you can see here, the oxygenated blood, okay, will transfer into the kidney via renal artery, and then it will goes to interlobar arteries. From interlobar artery, it will then transfer through the arcuate arteries, and then arcuate arteries to the interlobar arteries back, and then it will goes to the afferent arterioles, and then these afferent arterioles, and it will make up a glomerulus, okay, here, that looks like a ball here, and then it will go out from the glomerulus through the efferent neuron, okay, and then to the paratibular capillaries, it does not shown here, and then seterusnya, and continuously the same, but now it will exit through the renal vein. Okay, so the functional unit of kidney actually refer to the nephron. Okay, so nephron located at both sides of the renal cortex and also the renal medulla. It consists of small tubules that are important for the filtration process, and also they are associated with the blood vessels, okay, renal blood vessels, and each of the kidney has more than 1,000,000 nephrons. Okay, it's a lot inside our body. This one also. So the nephron, okay, here this is renal cortex, renal medulla, which refer to the renal pyramid. Okay, so the nephron structure includes the glomerular capsule, or also called as the Bowman capsule, that surrounds the glomerulus. Okay, actually inside here there are glomerulus, and then here is proximal convoluted tubule, and then we have loop of Henle, distal convoluted tubule, and last but not least is collecting duct. So now let's look more details on each part of the nephron. The first part is Bowman capsule. So Bowman capsule, it surrounds the glomerulus. Okay, glomerulus is actually a pile of the afferent arterioles. Okay, so what will happen here? So they will make up a structure that we call as a renal corpuscles. Okay, renal corpuscle, and then the filtrate that being produced in the renal corpuscle will pass through the proximal convoluted tubule, and then goes to the descending, okay, of loop of Henle and ascending loop of Henle. Why it called as descending? This part, okay, yang turun ke bawah ni, is known as descending. Meanwhile, the part that will goes to the upwards is known as the ascending loop of Henle. Okay, and then they will goes to the distal convoluted tubule, and then finally it will pass through the collecting tubules to the and directly to the ureter. Okay, okay, so this one. Okay, and after efferent arterioles here, tadi kan they will masuk into the they will make up the glomerulus. Okay, here is the efferent arteriole, and it will goes back. Will goes out through the efferent neuron, and then efferent neuron will make up peritubular capillary that will surround all of the convoluted, proximal, and also loop of Henle parts. Okay, as you can see over here. And then there are two types of nephron. The first one is cortical, and the second one is juxtamedullary nephron. So this type of nephrons is actually classified based on their location of their associated of renal corpuscles. So what does it mean? As you can see over here, okay, the cortical nephrons, mostly the nephron that located associated with the renal corpuscles that located at the superficial parts of the renal cortex. Okay, so this type of nephron, they have a reduced length of loop of Henle, is shorter compared to the juxta, and this type of nephron make up 80% of the nephron inside the human body. Okay, meanwhile for the juxta, okay, for the juxtamedullary nephrons, it associated with the renal corpuscle here that located near to the renal medulla. Okay, in which at the lower parts of the renal cortex. So juxtamedullary nephrons, they have a quite long loop of Henle compared to cortical nephron, and then they are better at making concentrated urine compared to the cortical nephron, and it make up of 20% of the nephron insides of the human kidney. Okay, now we're gonna look on the urine productions, where the nephron and the collecting ducts are lined with transport epithelium that will later process the filtrate into the urine. And our nephron can process up to 180 liters of filtrate per day. Is quite a lot. And then the transport epithelium processes will process this filtrate to form 1.5 liter of urine excreted daily. Okay, and the balance will be used by our body. Okay, so considering that you have 6 to 8 liter of blood, so this means that your entire blood volume get filtered approximately 20 to 25 times each day. And for the excretory systems, there are 4 important processes that happens in the kidney, in which the first one is referred to the filtration, where our blood will be the fluid from the blood will be filtered at the renal corpuscles, and then reabsorption will occur, where the filtrate, some of the substance from the filtrate will goes back to the blood vessel, and then we have secretions, where the blood vessels secrete some of the substances, and then later the filtrate will become urine, in which the urine will be excreted out from our body through the process of excretions. So now we're gonna look on the first process, which is glomerular filtration. So as you can see here, okay, this is the overview of the nephron functions before we goes into details of each process. This is the afferent arteriole. Okay, afferent arteriole, it will form structure that known as glomerulus. So this glomerulus is surrounded by the Bowman capsule. So together they will make up the renal corpuscles. And then the fluid from the glomerulus will filtrate into the nephron. In this one but here we call it as a lumen. Okay, this process is known as a filtration, and then some of the substances later will reabsorb back to the blood capillary, blood capillary, and then this one also, here also happen some secretions of substances from the blood capillary. So therefore, at the proximal and also distal tubule and collecting ducts, it involves two processes which are reabsorption and also secretion. Meanwhile, at the loop of Henle only involve reabsorptions process, and for the excretion later, it will happen at the urethra, our urinary bladder, and also the ureter. Okay. Meanwhile, the renal corpuscle only involve filtration process. So the filtrations of the blood, as I mentioned earlier, filtrations of the blood happen in the renal corpuscle. Okay. So as you can see here, what will happen at the renal corpuscle, the glomerulus, okay, will cause the filtration to occur by forcing the blood, the fluid inside the blood goes to the lumen of the Bowman capsule. Okay, and they are that filtrations of the fluid from the blood from the glomerulus is non-selective, but only for small molecules such as salt, glucose, vitamin, nitrogenous bases, and small molecules in concentration that's similar to the blood plasma. Okay, meaning to say they will force or they will filtrate the small molecule from glomerulus to Bowman capsule until they reach equilibrium, until the concentrations of these both sides is similar. Okay. However, not all substances can be filtered, okay, in the renal corpuscle because blood vessel and large macromolecules are not filtered, okay, into the renal corpuscle. Okay, only small molecules, okay, can be filtered. And then the renal corpuscle, which also known as glomerular corpuscle, okay, the capillaries are fenestrated. So meaning to say, the glomerulus, they have a large pore that can allow the water. Okay, here kita ada nampak very quite big pore that can allow the water and also small molecules to leave the blood vessels, or okay, to leave the blood vessel. It will goes to the Bowman capsules, okay, but not the large molecules such as the blood cell and also the plasma protein. So the fluid that successfully enter the Bowman capsule is known as the filtrate now. Okay. So next is reabsorptions of salt and water. So for reabsorptions of salts and water, okay, This one, it happens in proximal tubules, okay, distal tubule, loop of Henle, and also at the collecting ducts, okay. Meanwhile, filtration only occur at the at the renal corpuscle. So the reabsorption also process is selective on important nutrients only. It will reabsorb back from the nephron back to the blood. Okay, as you can see over here, some of the reabsorptions is referred to the active reabsorptions that involving active transport, and some of the molecules might reabsorb back through a passive transport. So as you can see here, the red arrows, okay, shows active transport. Meanwhile, the blue arrows shows the passive transport. Okay, and then so first reabsorptions of sodium ion. Reabsorptions of sodium ion is actively transported out of the filtrate. Here, they will goes out um, from the tubule, okay, to set up a concentration gradient and to drive the homeostasis, okay. The reabsorption actually also involving chloride ions, sodium ions, and also water that follow salt by osmosis. And the pumping of sodium into the interstitial space later will attract the negative chloride ions out of the lumen. Okay, it starts from the reabsorptions of sodium ion first, and then it will follow by the filtrations. It will follow by the reabsorptions of the chloride ion. Okay, back to the blood vessels. Okay, and then the third one is that the water will follow by the osmosis. Okay, and then the increased concentration of salt and water will diffuse into the peritubular capillaries, okay, that surrounds the nephrons. Okay, as you can see here, filtration occur at the Bowman capsule, and then reabsorption occur at all parts of the nephron, where the sodium ion will transport out first by active transport, and then followed by the chloride ions, and then it will follow by the waters, okay, through the osmosis process, which is also referred to the passive transport. And now let's look on what happened at the descending loop of Henle. The descending loop of Henle, okay, here what will happen, an additional 20% of water will reabsorb back to the blood vessel or to the peritubular capillaries, okay, from the descending loop of Henle. So this process happens continuously and is unregulated, okay, until the final of 15% of water is absorbed later in the nephron under hormonal control. And then the fluid that entering loop of Henle is isotonic to extracellular fluid. And then what is countercurrent multiplier? So the loop of Henle here and also the collecting duct, okay, this part, act as the countercurrent multiplier to create the osmotic pressure that will or the osmotic gradient that will facilitate the transport processes. And this process, the gradients are maintained by vasa recta capillaries, and vasa recta capillaries located at the lower part of the neurons. Okay, and the osmotic concentrations of final urine depends on the permeability of the distal tubule and also the collecting duct, which can be regulated. And if there are if the what we call that one, if the lumen of the nephron is permeable, so later it will produce a concentrated urine. So if it's impermeable, so it will produce the dilate urine. Okay, and water, okay, will not cross if it is isotonic to extracellular fluid. Okay, what does it mean by isotonic is that the concentrations of the solutes at the extracellular fluid is similar with the concentrations of the extracellular fluids. So of the extracellular fluid. So this one is referred to the osmosis process. Okay, and the structure of the loop of Henle will allow the concentration gradient to be set up for the home osmostasis, and then the ascending portion of or the ascending loop of Henle set up this gradient. Okay, yeah. Okay, so here what will happen? Okay, if okay the region of the medulla or the capillary is hypertonic, meaning to say they contain more solute at the outer part compared to the nephron. It will cause the water to reabsorb back to the medulla and to the capillaries part until it reach equilibrium. Okay. However, if the parts of the solutes at the medulla and inside the medulla and also capillary is similar with the concentrations of the solutes inside the lumen of the nephrons, that that condition is known as isotonic. So when the condition is isotonic, the water cannot reabsorb back to the blood vessel. Okay, and then here is descending loop of Henle. Then next we have ascending loop of Henle. Ascending loop of Henle, it does not involve the reabsorptions of water, but it involves the reabsorptions of salt, where the salt will actively pump back into the interstitial fluids. Okay, and then more salt will remove by the ascending limb, and therefore it will make up the fluid become saltier. Okay, and then as you can see here, okay, this part, the ascending loop of Henle is not permeable to water, but it's only permeable to an NaCl, meaning to say and only an NaCl can diffuse out from not diffuse, can be transported actively out from the ascending loop of Henle via active transport. Okay, and then for descending loop of Henle, it's permeable to water, okay, but it's not very permeable to the salt compared to ascending loop of Henle. Okay, ascending loop to naik, descending loop to turun. Where here, what will happen? The water is drowned out from the filtrate into the interstitial space, where it will be quickly picked by the peritubular capillaries that located around the loop of Henle. So this is a perfect for salt transport out of the fluid. into the ascending portion. Okay. Next is loop of Henle. This one is similar. It involving, as I mentioned earlier, the solute will be reabsorbed into the interstitial fluid from the lumen, from the descending loop of Henle. Meanwhile, water, and this part as a descending loop of Henle, this one is ascending. For descending loop of Henle, water is permeable, where the water will goes out to interstitial fluid and it will taken by the capillary. This one also similar. You can read by yourself later. And then for collecting duct, what will happen here? High concentrations of urea and NaCl outside the nephron, okay, deep in the kidney, help to concentrate urine in the collecting duct. Okay, the last process that happen in our nephron of the urinary, in our nephron of the kidney for the urinary system and also excretory system is referred to secretion process. Secretion process similar with reabsorption process, but however it is vice versa. So meaning to say, if we recall back, reabsorption is the process where the blood inside the blood capillaries, okay, will reabsorb back any substance, will reabsorb back substances from the lumen, okay, the lumen of the nephron back to the blood. Meanwhile, secretion is the process where the blood, okay, will secrete some substances to the lumen of the nephron, okay. So usually the product that being secreted by the blood is referred to the potassium, ammonium, hydrogen ion, pharmaceutical, and some water-soluble vitamins. And it requires transport of protein and also energy. So done for the four important processes that happen in the nephron, which is the first one we have filtration, the second one is reabsorption, and then secretion, and later the filtrate that become the urine will excrete by our ureter, goes to urinary bladder, and it will excrete out from the body through the urethra by the process of excretion. Okay, next, glomerular filtration rate. So what is glomerular filtration rate? So during the whole process that we discussed just now, you have to remember that we need also to calculate how many is actually the fluid from the blood plasma goes into our nephron, right? So glomerular filtration rate, GFR, is referred to the volume of fluid filtered from the glomerulus into the Bowman capsule per unit time. The unit time referred here is minutes, okay, not second. And the changes in the rate occur due to the changes of the glomerular capillary blood pressure, which later determined by three main forces. First is glomerular capillary hydrostatic pressure. The second one is Bowman capsule hydrostatic pressure and plasma colloid osmotic pressure. So let's look here more so that you can understand more. So this one, first we have pH here. This is the glomerulus. This one is Bowman capsule. So pH is referred to hydrostatic pressure or blood pressure from the glomerulus. And then P here is referred to the osmotic pressure, okay, from osmotic pressure that caused by the concentrations of the protein inside the blood plasma. And then last we have P fluid. P fluid is referred to the fluid pressure that created by the fluid of the Bowman capsule. Okay, so how to calculate the amount or how to calculate the pressure of the filtrate that goes into our Bowman capsule? So by the pH, okay, the hydrostatic pressure minus the color osmotic pressure minus the fluid pressure from the Bowman capsule, and then we will get the net filtration pressure. Okay, so therefore the rate of the filtration depends on the net filtration pressure. So I think that's all for today, class. Thank you. See you next week.